Welcome to the lecture series on blockchain technology. The goal of this series of lectures is to explain in growing detail and depth the technologies behind blockchain. In this third video of the first set or week, we will examine the blockchain network. As we have seen in the first video, the blockchain network is a distributed network. We will look at some properties that make this a useful network type. Propagation through this network will play a role in how it behaves, so we spend some time on this. Some things we take for granted in real life and other networks. They do not exist in the distributed network. Not all the nodes in the network are friendly. Bad or malicious nodes can also exist. Nodes leaving the network have some impact, but do not impact the functions of the network. Performance of the network will be impacted in some minor way. We briefly examine how a node might join the network. As shown here, the distributed network has nodes and connections. The nodes are not connected to all other nodes. There are also no special nodes that connect to many other nodes, like in the decentralized or centralized model. In reality, the network will not have an agile boundary like in this representation. This is an effect of drawing a schematic picture on a flat or two-dimensional surface. This network model is very useful for blockchain. There is no central authority or boss in this network. In the centralized network, the central node essentially controls the network. Nothing like this exists in this model. There is no center of the network or boundary. This network model scales well. It can be small or large. This model works at a global level. An example of a working global level distributed network is the peer-to-peer network used in BitTorrent. As expected, there are also disadvantages. We will come to these in later lectures. Propagation through the network is sequential. A message will not reach all nodes at the same time. As an example, let us look at two messages or transactions going into the network. Let us define a node A and a node B. Now let's assume that message M1 enters the network at A. And message M2 enters the network at B. A will send M1 to his neighbors, and B will send M2 to his neighbors. So B actually has one neighbor more. It is clear that node A and its surroundings will have M1 before M2. It is also clear that node B and its surroundings will have M2 before M1. And this process will continue, all of them sending the messages on. Some nodes will actually get the same message from two sources. get the picture. The nodes at more or less equal network distance from A and B will receive M1 and M2 at more or less the same time, but it is not clear which one will arrive first. This effect of propagation of messages in the network leads to some interesting effects that we will see later. In this distributed network, some concepts we take for granted do not exist. There is no central concept of time. Each node has its own clock. This also means that all nodes at the same time is not a concept that is present in a distributed network. Or a simultaneous operation like at 11 all nodes will perform an operation does not exist. There is no numbering or specific ordering of nodes. And as we saw on the previous slide, information reaches nodes in different order. Also, the nodes in the network do not all need to be in the same state. These properties lead to some interesting consequences. As mentioned before, individual nodes may leave. Let's say that node either leaves the network or fails. This means the connections from it also disappear. We are left with a hole in the network. This has consequences for the communication between nodes. Where A and B used to be able to connect via the now missing node and only take 2 hops, they now have to take more hops, but they can still communicate. When you want to join the network, you need the right software, and you need to know at least for one node that is currently functioning and part of the network. Assuming those conditions are met, how does it work? Node A wants to join and knows B as part of the network. Node A talks to B and requests some more nodes close to both of them. B sends some information back. A can now connect to more nodes. A is now part of the network and can request data from its neighbors. Also, A can now send and receive messages to and from its neighbors. This concludes this video and this lecture series. I hope you enjoyed it. The next video will go into the consensus model. For questions or suggestions, please contact me on the email address shown. Thank you.